Let's check out 5 questions from the June 2023 Chemistry Regents exam that were a little bit interesting this year, starting with question number 8. In this question, it's asking you about balancing the equation in terms of mass and energy. In other words, it has to be balanced, and then we have to have energy on the correct side of the equation. Well, let's tackle one then the other. For mass, we're going to balance, and if you take a look at choice 1, while I have a carbon on both sides, I have 4 hydrogens on the left and only 2 on the right, which makes it right away unbalanced. So let's just cross it out. For question 2, it's exactly the same thing. I didn't even get to the oxygen, but again, the hydrogens, 4 on the left, 2 on the right, it's unbalanced. I get to choice 3. I have 1 carbon on the left, 1 on the right, 4 hydrogens on the left, 2 times 2, which is 4 on the right, 4 oxygens on the left, and I have 2 plus 2 times 1, which is 2, so 2 plus 2 is 4. It's balanced. It's the exact same equation here in choice 4. The only difference now is, am I adding energy, which would make choice 3 endothermic, or is energy being released, that making choice 4 exothermic? Well, to answer the last part of energy here, we have to go, of course, to reference table I. Here at reference table I, right away, the first equation is the same equation from question 8, and you notice it's a negative 890.4. If you forget the negative sign, tells me it's exothermic, and it should be a product. You can go ahead and scroll down to the bottom of this table, and it will tell you the exact same thing. Therefore, that makes the answer here for question 8 choice 4. Not that it was that hard, but it is a 2-part question, and you have to go to the reference table. Haven't seen this question, either haven't never seen it or haven't seen this one in a while. For question 32, you're calculating atomic mass. There's one on every Regents exam, but this time it was a little bit different, and hopefully nobody got this wrong who's watching the video. What I say to my students is you have to get mad. You're going to multiply the atomic mass and the natural abundance. You're going to add them together, and then you're going to divide by 100. See, the percent means automatically you're going to divide by 100. The choices normally are set up where you might get something like choice 1, where there's no dividing by 100, so it's not the answer. But then you go to choice 2, and New York State would have slid the decimal over to 2 places to the left, which is dividing by 100 for both. It didn't do that. Instead, they went ahead and just kept the percent sign. And that actually makes choice 2 the answer. So a little bit of a twist on the same type of question that comes up over and over again. Question 44 is an interesting question. It's a potential energy diagram question. They show up, but usually we don't see them where you're going to go ahead and they're going to give you the values here on the y-axis of 100 kilojoules for each line. Now you're asked about whether the reaction is endo or exo. You're starting low, you're ending high. That makes it endothermic. And then what delta H, or the heat of reaction, is. And it's the energy of the products minus the energy of the reactants. So now you need the value. Well, each line is 100, so it's 100, 200, 300. So it's going to be 300 minus 100, which is from here. And of course, you know the answer is 200. And since it's endothermic, it's a positive 200. If we go down to the choices, once again, this is a 2-for-1 type answer. You got to answer 2 questions. First is endothermic. It's not exo. You can cross out choices 3 and 4. And then it should be a positive 200, which is choice 2. For question 50, you're looking at a nuclear equation. Of course, your mass on the left is equal to the mass on the right. And normally that's the way we balance the equations. But here, we're using Einstein's E is equal to mc squared equation. And when I add up the total mass on the left-hand side, and 2 times the mass of the helium on the right-hand side, they're not equal. The reason they're not equal by a very small amount is that mass is converted into energy. So that's all you're doing. Add up the two numbers on the left, subtract that from 2 times the 4.0026 on the right, and your answer is choice 1. Okay, the last question here is for question 72. You're actually asked, instead of just calculating a gram formula mass, you're actually asked to show a numerical setup. That is totally a new twist. Now, the other thing that was happening is you're asked the gram formula mass for NO2 in equation 2. We had a lot of students that weren't sure, should they distribute the 2 to the nitrogen or the oxygen, or just calculate it for NO2? The real answer is just calculating it for NO2. How do you show the setup? Well, what I teach is you're going to list the elements, the number of times they appear in the formula, get the masses off of the periodic table for the individual elements. You're going to go ahead and multiply them out and add them up. That would have been a numerical setup. That's the 5 questions I found this year with a twist. Check back in a week or so, and I should have the rest of the explanations up for the June 2023 Regents exam.